So this video is about conditional probability. And the first thing to know is the conditional probability formula is this. It basically says probability of B given that A has occurred. So this that bar there means given that A has occurred. So the formula for it is probability of A, and this thing here, this symbol means and, A and D. So it means probability of A and B over probability of B. Probability of A. So again, that symbol means and. If you think about the Venn diagrams, the and section would be this middle section here. That would be the section where A and B also occurred. So I'm looking for the place where they overlap. And this is a symbol actually for the place where they overlap. If you don't see this number, like usually we have this number, we can figure out this number. But if you don't have it, that formula, probability of A and B, basically means the probability of A times probability of B. If they are independent events. All right, if they're independent events, meaning that one is not affected by the other, or having one to happen doesn't affect whether the other one could happen or not. It changes though if they're dependent events. If they're dependent, probability of A and B equals probability of A plus probability of B. And this is if they are dependent events. All right. Probability of example of independent events is like flipping a coin. If you flip a coin once, flip a coin again, it doesn't change what the outcome could be the second time. So they're independent events. Example of dependent events is like drawing cards out of a deck of cards. Every time you draw one card out, it changes the probability of getting the next card because now you have fewer cards in the deck. So they'll be dependent events, and their sum should equal to 1. Well, if you add them all up, probability of all the different possible outcomes, all those probabilities should add up to 1. This assumes you only have 2 outcomes. So if you only have 2 possible outcomes, that sum would add to be 1. All right, so those are the formulas. Let's talk about how to actually use them now. All right, so here we are. All right, so this is the first example. In a group of 100 students, 40 are taking algebra, 30 are taking biology, 20 are taking both algebra and biology. So let's write that up. So you got 100 students, 40 are taking algebra, 30 are taking biology, 20 are taking both algebra and biology. So let's create the universe. This is my universe. In this universe, we got 100 students. This is my algebra class, and this is my biology class. And they gave me some data to start with. They told me that 20 students are taking both algebra and biology. So that's 20 students in this bubble. So that's used. And then they said that this is ALG here. Anyway, and then they said it's 30 students taking biology. So it's 20 already used. It's 10 people left taking biology. So that's used. And 40 students are taking algebra altogether. So 20 used here, these 20 students there. All right. So that leaves, you got 20, 40, 50 students. That leaves 50 students not taking any classes. All right, so that's all true. Now, the question asked, if a student is chosen at random, all right, what is the probability that, if a student's taken at random, is taking algebra, what is the probability he's also taking biology? So basically, it's already given that he's taking an algebra class. So this is what we have. What's the probability that, given that he's already in algebra, that he's also taking biology? All right, so the given is, so this is going to be the probability of algebra and biology over the probability he's taking algebra. All right, so that's true. I know this intersection. This says the intersection of algebra and biology, that's 20. So the probability of taking that is 20 out of 100. So this piece is 20 out of 100. It's the probability of taking algebra or biology, or about 0.2. And the probability of taking algebra is 40 out of 100. All right, so this is a decimal. I'm gonna write it over here. This is 0.2 divided by 0.4. So this is about 50%. So the answer to this is 50%. Or you could have said 0.5 and it's not right as a percentage. So the probability that a student is taking biology, is also taking algebra, is 50%. Well, not also, probability of a person taking biology, given that he's taking algebra, is 50%. All right, and that's different from this probability of taking biology, right? Probability of taking biology is 30 out of 100, but probability of him taking biology, given that he's already in the algebra class, is 50-50, which makes sense. 20 of them here and 20 of them there, so it's equally likely. All right, so that's one example. Got another example. All right, so new example. This example is about smoking. So, a study examined residents in a mining town to see if the mining operations had an adverse health effects. The table at the right shows the percentage of respondents who had either two health factors related to lung cancer and lung cancer itself. So the first thing says, finish the table by adding the total rows and columns, and then we answer these questions by probability. So what they mean first is, we'll first find a total here. So this is total. And add up all the ones in this row to be this total. This is the bottom of it, a different total. Add up all the ones in this column for those. So with the calculator, you can add these just as well as I can. I'm just going to fill in these blanks here. All right, so if you add 12.9 plus 6.05, you should get 18.95. Use a different color from here on out. And if you add these numbers, you should get 10.1. Adding these should give you 9.15. Adding these, you should get 61.8. These numbers added for the lung cancer column is 31.55. And the people who didn't have lung cancer at all should be 68.45. If you add all this up, it should be 100%. All right, so all you add up all these should also be 100%. All right, so that's the first thing. We fill out the table, so that's done. Check. Next thing says, what is the probability given that the respondent picked at random? That respondent is picked at random. That both had lung cancer in their family history and smoked. All right, so this number represents the percentage of people that had lung cancer, but they had smoke. They were a smoker, and also they had cancer in their history, in their family history. So this percentage of people who actually had that. But here, these people are smokers too, and they also have lung cancer in their family history, but they didn't have any cancer whatsoever. So to answer this question, you want to randomly select someone that responded to the survey, and they both had cancer in their history and they smoke. There's a sum of both of those. So the answer there is 10.1%. This is 10.1% of all the people who responded to that survey either smoked and also had family history of having lung cancer. All right, the third one says, what is the probability they had lung cancer given that they were a smoker with no family history of cancer? So this is a probability question. Given that follows a bar. So it is given that they were a smoker with no history. So they're a smoker without history. This is a given part. The part comes before given is had lung cancer. All right, so you want to know the probability they're going to have lung cancer given that they're a smoker with family history. So that probability is probability of them as a smoker without history. And they also have lung cancer over probability they're a smoker without history. Yeah, and that W/O means without. All right, so let's figure out what we can here. The bottom of the bracket says smoker without history. All right, so this is the row of all the people who smoke with cancer and without cancer, and these are the people who smoke with a family history of smoking. So we're not talking, family history of cancer. So we're not talking about these people. We're not talking about these people who have family history of cancer. Or we're not talking about people who have neither factor. We're talking about just people who smoke and don't have a family history of having cancer. So that total is 18.95. So all the people who smoke without a family history in the survey are the ones with cancer and without cancer. That's 18.85. So on the bottom is 18.95%. And on the top, we want to know the conjunction of what happens when we have a smoker with history, without history, and also has lung cancer. So we're looking for a smoker without family history and also has lung cancer. We're talking about just that 12.9. So it's 12.9% has that. So when you finally finish that, you reduce that, you might call it a percentage, and that's about 68.07%. That would fit this. So it equals 68.07%. They will have lung cancer given that they also smoke without a family history. All right, last example. All right, new question. In a group of 100 students, 40 were randomly put in an art class, a Monday art class. And independent of that event, 30 students were randomly put in a Tuesday botany class. If a student is chosen at random, is in an art class, what is the probability that he or she is in a botany class? So this is our probability. Given if a student is chosen at random is in art class. So given is they're already in art class. And we want to know the probability of them actually also being in a botany class. All right, so this is what we have. So the probability of that is the probability of art and botany over the probability of art. All right, so I'll create my little universe. And in this universe, I got my art students, I got my botany students. And they didn't tell me how many was in this section that overlapped. Since I don't know that, I know the probability of art and botany is equal to probability of art times probability of botany. So probability of being in art is 4 out of 100, 40 out of 100. Probability of being in botany is 30 out of 100. So that probability is 12%. So it's plain old 12%. So the answer should be 0.12 over 0.4, or 30%. That's all I have. Good luck.